Cambridge University, 1669. A brilliant 26-year-old mathematician is starting to think about the universe.
Sir Isaac Newton is one of the most remarkable scientists who ever lived. He was capable of addressing a problem and worrying it for months and years on end. Many people would, of course, get bored with something or give something up. He had that extraordinary persistence. And he starts to work on a number of key problems in physics.
One such problem is the performance of the telescope. Astronomers want to study the planets of the solar system, but their telescopes aren't up to the job. To see these faint, distant objects in the night sky, telescopes will have to capture more light, and for this, they will need bigger lenses. The purpose of the lens is to focus all the light to a single point. But a bigger lens leads to big problems for the early astronomers. Newton had discovered that shining light through a piece of glass bends the light and splits it into different colors. The same thing happens when light is passed through a glass lens, but the lens brings each color into focus at a different point. These multiple points of focus cause the image to appear blurred. The bigger the lens, the more the image will appear out of focus. In his Cambridge study, Isaac Newton believes he's found an answer to the problem. A way to make a telescope which produces crystal clear images without the colors blurring. He removes the troublesome lens and replaces it with something entirely different.
This is the world's first reflecting telescope, made by the young Sir Isaac Newton in 1671. He made it in his rooms in Cambridge from perfectly acceptable ordinary materials of the day. Cardboard tubes, a wooden ball to do the adjusting with, but a mirror replaces the lens down here.
Newton's mirror is a metal disc polished into a concave shape. It reflects the light from distant objects to a single point. A second, smaller mirror then bounces the light into an eyepiece. Because the light does not pass through a thick lens, there is no separation of colors, and the image is not blurred. By reflecting the light, Newton's telescope produces the sharpest images in the world.
And that telescope made people's jaws drop in the Royal Society in January 1672, because it was more powerful and gave a better and clearer image than a conventional telescope of 6 feet long.
From this point onwards, the story of how telescopes evolve is a story of mirrors, not lenses, getting bigger.